Okay, hello everyone. Let us now proceed to the second example for the ellipse. Now this is a little bit different. So this is a variation of the problem. So given the equation 9x squared plus y squared is equal to 9, perform the following. First, we need to convert the equation to standard form. Then determine the location of the foci and the vertices and the graph of the equation. Okay, so convert the equation to standard form. So what exactly are our standard forms? So the standard forms are x squared over a squared plus y squared over b squared is equal to 1. Now, what is this standard form again? If the major axis is on the x-axis, okay? So, meaning our ellipse is elongated along the horizontal like that. So, let's take a look at the other general form, standard form, which is x squared over b squared plus y squared over a squared is equal to 1. So what does this mean? The major axis is on the y-axis. Okay, so our ellipse will look like this, elongated vertically. Okay, so let's rewrite our equation here on the right side. 9x squared plus y squared is equal to 9. So as you can see, it is not in any of these two forms, right? It's not in any of these two forms. So what we can do here, based on observing the general forms, as you can see on the right hand side, it is 1. And the coefficients of our y squared and x squared are both 1, right? Same is true for the other general form. So if we want to convert this given equation, the first thing that we can do is to divide both sides by 9, right? So if we divide both sides by 9, we will get x squared plus y squared all over 9 is equal to 1. So as you can see, it is already in our standard form. Now, you might say that there is no denominator in the x squared, but as you know, there is always x squared over 1. Okay, so what do we do next? So what we do next is to determine the location of the foci and the vertices. Okay. So finding the location of the foci and the vertices, so we need the value of C for the foci and the value of A for the vertices. Okay, but first we also need to take a look at our equation first. So as you notice, x squared x squared and y squared here have no transformations. Like in our discussion for the parabola, the shifting of the parabola, there is no x minus 1 squared or y plus 2 squared, like that. So if that is the case, then we can say that the center of our ellipse is on the origin. Okay, so that is a very good clue that we can use here. So once we find our A and C, then we can determine, we can answer letter B. Okay, so how do we do that? Okay, so let's copy our answer here on the lower part. So x squared all over 1 plus y squared all over 9 is equal to 1. Now, if we observe our answer, our equation in standard form, we notice that the denominator of y squared is actually larger. Now, this means that our ellipse is elongated vertically, right? So we are going to use this general form instead of this one. So we're going to use that one. So let's write it down here. So x squared all over b squared plus y squared all over a squared is equal to 1. So let us now compare the denominators right here. So b squared is equal to 1. So therefore, b is actually positive negative 1. And then for our a right here, so a squared is actually a 9, right? So a is equal to positive negative 3. So how do we find our c? We already have our a. We can conclude that our vertices are at 0, positive 3, right? 0, positive 3, and 0, negative 3. Okay? So that is where our vertices are, because our major axis is on the y-axis. Okay. Now, if we want to find c, we use the Pythagorean relationship between a, b, and c. So a squared is equal to b squared plus c squared. Now, c squared is equal to a squared minus b squared, and if we substitute the values, we get 3 squared minus 1 squared. So c squared is equal to this is 9 minus 1, which is equal to 8. So c is equal to positive negative 2 square root of 2. Okay, so now that we have our c, we can say that our foci are at 0, negative 2 square root of 2, and 0, and 0, 2 square root of 2. Okay, so there we have our answers. So this is the location of our vertices. These are the location of our foci. Now, if we try to graph this one, so just an estimate. So we will get, let's say this is 3, negative 3, the negative 1, 1, and a foci are right there. So we can then just connect them like that, and you will get the approximate graph. If you want to take a look at the accurate graph, here it is. Okay, it's very awesome indeed. So there you have our vertices and our foci right here, and our semi-minor, our minor axis and our major axis. Okay, so that's it for this video, and I hope you learned something, and I will see you in the next one.